we're gonna for some of these, we're just gonna get to the point where we can solve them and say, okay, Mr. Out, we know what we're supposed to do. Very rote kind of process there. Step 1, draw an appropriate figure and label the quantities relevant. Step 2, find a formula that needs to be maximized or minimized. This is called the mathematical model. Step 3, using conditions stated in the problem to eliminate variables, express quantity to be maximized, minimized as a function of only one variable. Step 4, find the interval of possible values. This is domain. Step 5, take the derivative. You know what, I would get very upset at kids if they actually, if you always did it in this order. I just want you to know what you're supposed to do. So if I say find two numbers whose sum is 20, you should be able to write me a little mini equation that says that. X plus y equals 20. I don't need a statement, let x be the first number, and let y be the second number. So x plus y equals 20. And whose product is as large as possible. Well, x plus y is 20, and whose product is as large as possible. Product equals x times y. So you've done everything from step 1 up to step 4 by doing that. There's no domain restrictions. There are no range restrictions. Solve for y or solve for x. Take a choice. X equals 20 minus y. Okay. Take that and put it over into the P formula. P equals 20 minus y times y. Multiply out your brackets. 20y minus y squared. Find the critical point. Find the critical point. Take the derivative. Make it equal 0. Don't have to do anything implicitly here because you have y as an independent variable and p is your dependent variable now. So p prime equals 20 minus 2y. Don't have to do it implicitly. Make it equal 0. Solve for y. Y equals 10. Make a conclusion about x now. X is 20 minus 10. X is 10. What's the product? 10 times 10, 100. Remember questions like this in Math 11? Okay, now how do we know that this is a maximum? All we've done is found the critical point. Critical points can be maximums or minimums. Do we have a test that allows us to check for maximum and minimumness without doing a heck of a lot of work? What is it? Nah, you don't want to do a table. I'm lazier than that. What does the second derivative test allow us to do? See if it's concave up or concave down. If it's concave up, we just found a minimum. So what's P double prime? P double prime is -2. Is that number bigger than 0 or less than 0? Less than 0. It's concave down. So we know all of this stuff here. We know this is you're finished. It's a maximum area. Do you want to see what you had to do in Math 11, or do you want an incredible sense of deja vu? Do you remember completing the square? Do you want to complete the square? I hate it. It's too much work. You're right, it is. Okay, next one. A formula of a rectangle with a perimeter of 100 meters. Take that rectangle with perimeters. Take that box and make equation. Okay. Whose area is as large as possible. Take that sentence and make me an equation. Area is x times y. Ooh. So we've done the question. Now we're off to pick a variable, x or y. X. Okay. Solve for x. Make it x equals 100 minus 2y equals 2x. Divide by 2, divide by 2, divide by 2. 50 minus y equals x. The area formula becomes $50 minus y times y. What are you going to do? Then what? Y. Because you need to find your critical points. Okay. What's y equal to? 25. What's x equal to? 25. What's the area equal to? 625. Good. How do we know if it's a max or a min? Take the second derivative. A double prime equals -2. If it's negative, it's concave down. It's a max. You guys picking up what I'm laying down? Step 1, make a formula. Step 2, make another formula. Step 3, take one formula, sub it into the other one. Step 4, take the derivative. Step 5, find the critical points. Step 6, find the concavity. Step 8, pick up the sticks. No, wait. 1, how does that go? 1, 2, buckle your shoe. 3, 4, lock the door. 5, 6, pick up sticks. 7, 8, ain't that great? 9, 10, do it all over again. Isn't that how that goes? Wasn't that fun? I don't know. Maybe it is. I didn't pass kindergarten, so I couldn't play well with others, John. Those are my toys. What is the smallest perimeter possible for whose rectangle's area is 64 square centimeters? Perimeter. Perimeter is 2x plus 2y. Its area is 64. Solve for one of the variables in the equation that has the number in it. Y equals 64 over x. Ooh, this is going to be excited to solve for x so many times. P equals 2x plus 2 times 64 over x. Get all math 10 and 11 on it. 2x plus 128, that's the -1. Take the derivative. dP dx. Or P prime equals 2 minus 128, x to the -2. Make it equal. Yeah, and we do it again, and again, and again, and again, and again. And again some more. 2 minus 128 over x squared. So you switch it back into a fraction because now we want to clear denominators. Multiply everything by x squared. And you get 0 equals 2x squared minus 128. Now what? Solve for x. So move the 128, divide by 2. You get x squared equals 64. Okay, x equals plus or minus 8. But then you recognize that you are talking about perimeter and area. And when you're working with grade 8s over the next little while, everybody get a ruler out and yell at the kid until they draw a side length of -8 centimeters. And say, what are you doing wrong? I asked you to draw a line that is -8 centimeters long. No, that's not right. No, -8 centimeters, not +8. You keep on hitting them. Right? Can you have a side length of -8 centimeters? No. Someone's going to try and do this. This is not good teaching practices to hit children. There you go. So you know x is 8, you know y is 8, and you know it's a minimum because when you take the second derivative, you get p double prime. The second derivative is p double prime equals 0 plus 128 over x cubed. And when you put +8 in for x, you are going to get a positive number. Positive number means concave up. Concave up means a minimum. Okay. Oh yeah, whatever, 256, sorry. Is it a max? Find the small. What is the smallest perimeter? Well, when x is 8 and y is 8, the perimeter is 8 plus 8 plus 8 plus 8. 32. Because that tells if it's a minimum or a maximum without actually doing work. Now you're thinking to yourself, there's only one critical point, so it has to work. But there are a couple of questions later on that you're going to get two answers. One's going to be a min, the other one's going to be a max. And unless you check the concavity, you don't know. Right? Okay, flipping page. Okay, we're just going to set this one up because you're going to have this OMG moment. A farmer has 200 meters of fencing and he wants to fence off a rectangular plot along a straight river. Where have you heard this one before? If you were in my Math 11 class, it would have been about Billy Joe Bob fencing off his grade 8s. Because you can't have grade 8 boys and girls in the same pen because all sorts of bad things happen. And they're too young for CAP and sex ed in grade 9. So we just keep them in separate pens. What? It's completely inappropriate? Yeah. Anyways, so we've got these pens, and then somebody says maybe it's not river, maybe it's lava. We have these big lava fields, so we don't need to. Are you making fun of me? What? Oh. So we've got a lava field, maybe. And we got to keep our cows inside of our rectangular pen. And now cows are pretty smart. They know not to go into the lava. But where would you have a lava field with cows? It's my universe, so I'm allowed to do whatever I want. So we make our little formula. X, y, 2x plus y equals 200. Solve for the easiest variable. Write an area statement for our pen. incredible sense of deja vu. Multiply it out, take the derivative, set it equal to 0. Find the critical point. Yeah, well, I'm going to stop here. I think you get the idea how that one's going to continue. Yeah? Give me a thumbs down if you want me to continue. Okay. Just checking. 200x minus 2x squared. Anyways, we'll stop there. Take the derivative, set it equal to 0, blah, 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 blah. Okay, read the next one. An open box is to be made by cutting squares out of the corners of a piece of cardboard 16 centimeters by 30 centimeters. Yes? Painful. Okay, well, let's just set it up then. Volume equals length times width times height. So then we all took our pieces of paper and we cut little squares out and we taped up the sides and we went length times width. Remember doing that? No? And you were measuring the volume, and wasn't that fun? And then there's the kid in the corner. Sorry, I'm mocking kids that aren't in this class. I don't get it. Really? Sorry if I'm mocking anybody in this room right now. 16 minus 2x, 30 minus 2x, and x. So the next thing that I would have had my grade 11 class do, because you know what, I do this activity with my grade 11s as well. I'm just as bad as the rest of them. When did I last teach grade 11? Probably 3-4 years ago. But I can tell you exactly what you do in each section. If you throw a section number out at me, I will probably tell you what it's about. Yeah, pretty much. I love math. I love math. And then we take and we multiply it out. 16 times 30, I don't know. Is that 480? What is 16 times 30? 480? 16 times 2 is minus 32x squared. 2 times 30 is minus 60x squared. And then plus 4x cubed. Okay, math 11, we wouldn't have made you do this. We would have just had you graph this one and find the maximum. But I'm avoiding the product rule because I just don't want to do it. I'm cleaning this up. 4x cubed minus 92x squared plus 480x. Now, what are you going to do from here? Take the derivative, set it equal to 0, and solve for x. This one's going to have two answers. One of them's going to be a max. The other one's going to be a min. Yay! So you need to do the second derivative test here. Because you need to know, do you want the max or do you want the min? So that second derivative test is required for this question. Well, there is another way of doing it because you know what? Sure. Yeah, but I don't want you to do that. I want you to use the second derivative test. Okay? The other way to do it is to know the domain of the function because x actually has to be in this domain. And you'll get an answer that's outside the domain, and that's where the minimum is. It's outside of that domain. Where does that domain come from? If you have a box 16 by 30, if you cut squares of sides 8, you're actually doing this. Well, how much volume does it hold? If you make squares of side 8, you're actually just folding the paper in half. Half of 16. You have to visualize cutting a square of size 8 out of each of the corners, well, your scissors would be right in the same place. So you'll have this box that's like this. It'll just go, make a box. You can't actually make a box. And if you cut out squares of size 0, and everybody folds up the sides to make a box, visualize that. Look at the box. Look at its volume. Okay, so you can do that as well. If you knew the domain of the question, you'd know that one of the answers. You get 3 1/3 and 12. 3 1/3 is in the domain, 12 isn't. Yeah, this is basically about how to do Math 11 easier. Oh, critical points? Yeah, everybody used the product power rule. Well, we could have, sure. You're right, we could have. I'll go tell the Math 11 teachers to teach calculus. Limit statements and all that good stuff. Actually, it's not hard. Grade 11 kids. Some grade 11 kids could do that, sure. This class, no problem. But think about some of your colleagues. Whoa! That was a bit of a burn. Okay, find the least amount of lumber that will be needed to form a box, an open box with a square base and a capacity of 32 cubic meters. So you can all laugh at me and my inability to draw things with square bases. Well, that's not bad for me. So do I. So visualize something that's got a square bottom and a height that isn't the same. So you can make a formula for the volume. X squared y equals 32 cubic meters. Solve for the easiest variable. Y equals 32 over x squared. And then it says find the least amount of lumber. So you need to think, what is that talking about? Surface area. Dun dun dun. What's the area of the bottom? X squared. What's the area of the side? How many of them are there? 4. No, there's open box, so no top. So we can chuck our grade 8s in. Chuck. Grade 8s. They can climb out, yeah, I know. We'll put some killer cows at the top or something. Chucking our grade 8s in the box. Keeping them in there. What? Well, we could put them in there gently. We just don't want them to get out. What's that? Killer lava cows. That would do it. I don't know what a killer lava cow looks like, but that would be cool. 128 x to the negative 1. Take the derivative. 2x minus 128 x to the negative 2. Make it equal. Am I going too fast? I'll stop for a second. You guys were just visualizing the killer lava cows. Moo. And then lava would flow out. Moo. No? I don't know. Okay. 0 equals 2x minus 128 over x squared. Multiply everything by x squared. And you get 0 equals 2x cubed minus 128. Move the 128, divide by 2, you get 64. The cube root of 64 is 4. So you know x is 4, you know y is 32 over 16, 2. And you know the surface area is 4 squared plus 4 times 2 times 4. 16 plus 32, 48 square meters of wood. How do you know if it's a max or a min? Take the second derivative, fire 4 in for x, and if it's negative, it's a max. Right? Okay, so all of the questions up to now are pretty much Math 11 standard fare, hey? Maybe the last ones aren't, because you never really dealt with rational functions much. You might have graphed those only. You would have never been asked to complete the square with those. Okay. The last two look like AP, smell like AP, and taste like AP. Yep. Actually, it looks like contest problems, too. Like if you've done any math contests over the last little while, this one should have a flavor or ring of math contest to you. Yeah, it's the last page. So, find the area of the largest rectangle that can be inscribed. Inscribed means drawn inside a semicircle with a radius of 2. So what I'm saying to you is this. Yoink. And then we're going to put the rectangle inside. But the trick to this question is to do this. And it's almost appropriate that I'm wearing this shirt today. Almost appropriate. I could put a moose on it there and it would be the same picture. So, a circle with a radius of 2. This distance is 2. This distance is x. This distance is y. Write a relationship between 2x and y. Solve for a variable. What are we solving for? Y equals 4 minus x squared, square rooted, plus or minus. And then you throw up your hands and say, but Mr. App, all of this has been about distances, quantities of length, so it can't be minus. No negative. Okay? It's not positions in space we're talking about here. We are talking strictly about lengths. Okay? So the negative goes away. Bye-bye negative. Okay, find the area of that blue rectangle. X times y, almost. 2x times y, yeah. Area equals 2x times y. Whoops. Take that formula for y, put it in there, 2x. How are you going to find the maximum area? Derivative. Product rule. Derivative of the first. 2 times the second root 4 minus x squared plus the derivative of the second. Chain rule. Derivative of the inside derivative of the outside times the derivative of the inside. That's the derivative of the second times the first. Can you see why this one's AP kind of quality or level of difficulty? Because you need a product rule and you need the chain rule to do it. The other one, the first ones are like calculus 12 kind of questions. The derivative of, okay, so let's come up here and we'll do a little bit of scribbling. U equals 2x. U prime equals 2. V equals the root of 4 minus x squared. b prime equals 1/2 4 minus x squared to the negative 1/2 times negative 2x. Okay, almost ready to clean this up a whole bunch. So you get 2 root 4 minus x squared plus negative 4x over 2. 4x squared, yeah, good call. Over the root of 4 minus x squared. Cancel the 4 and the 2, good. And while you're there, make it equal 0. Oh, I really wanted to make it equal 0. Anybody like fraction? How are you going to clear the denominators? Multiply by the root of 4 minus x squared. Beautiful things happen when you do this. It's almost like a big conspiracy theory has happened. Oh yeah, sorry, good call. I make silly mistakes all the time. Oops. Oops. So you get 0 equals 8 minus 2x squared minus 2x squared. Move the 8, divide by 4, square root it. You get the root of 2. Don't you? Why isn't it negative root of 2? Because it's positions, it's not positions, it's distances. Yeah? Okay, last one. Yeah. It is. Do I ask more than one on a test? No. Is this a written question? Yes. Yeah, and then I'll tell you the area. Yeah. And you take the second derivative, and lo and behold, it's a max. You know, like a rectangle has its base on its x-axis, and it's okay. What are we going? We're gonna just start this one. So I want to see if you guys can start this one. So a rectangle has its base on the x-axis, and its upper two vertices are on the parabola y equals 16 minus x squared. What is the largest area the rectangle can have? What does it say? Can have, and what are its dimensions? So, give me something we can do to start. Draw a picture. Good. What picture are you going to draw? Okay, that's always a good thing, yeah. What else are you going to do? On the x-axis. Okay, what else are you going to do? A rectangle in like this. Okay. Just checking. Like what? Okay, good. Touching the parabola on both sides. What else? Pardon me? Draw a y-axis. Good. Now what? Well, you know it's 16 comma 0, but or 0, 16. Sure, but that I'll tell you that doesn't matter. Well, start with a quantity that you do know, or sort of know. What is this distance? X, is it not? What is this distance? Okay, now look at your formula. Somewhere on the page I tell you about y. How do I find the area of that blue rectangle? What's the area formula? 2x times y. What's my next formula? Of the whole blue box. Take the derivative, make it equal 0. Hey, look, you're going to get two answers. But then it says area, and you immediately, alarm bells go off. Look at the picture you've drawn. X is a positive quantity on your drawing, blah, 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 blah. Right? It's easy. Sorry, it's not easy. This is easy now. It's getting it to this stage is the hard part. Would you agree? Like doing the math here isn't difficult. It's getting it to this point. So you have to be willing to draw a picture. You have to be willing to label the drawing and go, well, I know this and this is this, so then maybe I can do some things. That's what's difficult about this. But I mean, if you look at the other previous questions, I was talking about rectangles and boxes. Was that too bad? The hard one is if I make it a soup can. You might get it on an assignment. Might. Will. Anyways. Written question from this section, automatic. I love the process. I love to see the second derivative test. I love to see all that knowledge. Are the derivatives hard, though? Like, if you look at these questions, are the derivatives difficult? No. The only part you're going to have to challenge yourself with is what are the two equations I'm working with? Okay? Additional questions, you don't have to do those unless you want to. You've got that assignment from me. You got an hour, 45 minutes. You can work on anything you need to work on, but that assignment is due Monday. Monday. Okay? Monday we will have a conversation about when our Chapter 4 test is, because I'm off at provincials Wednesday, Thursday, Friday. So we have to figure out what we're doing while I'm not here. Mr. Howell's coming in, but I don't know if you want to do the test until I'm back, or do you want to do it while I'm gone because you don't need me as much? What? Well, we'll talk. We'll talk on Monday. But you can start reviewing now if you want. Anyways. Yeah.